Hi, Nick from Holbrook Landcare Network. In this presentation, I'm going to present to you the findings from our soil health project. The aim of the project was to create a soil health snapshot of the region's main soil types, farming systems and rainfall zones. We did this by sampling 16 pasture paddocks across the region, from Drogery in the west to Tumbarumba in the east. These 16 pasture paddocks were across 4 different farming systems, 3 rainfall zones and 6 soil types. And here are the 16 sites located across the region. The soil sampling was completed over 2 stages. The first stage involved sampling the 0 to 10 centimetre topsoil layer, and these samples were sent to laboratories in South Australia and northern New South Wales for a range of microbial tests. We also did the soil Urundi's test, which is a novel way of measuring the abundance and activity of soil microbes, specifically the generalist feeding bacteria and fungi that break down plant materials in the same way. During this stage, we also did a range of other biological and physical field tests. The second stage of soil sampling involved revisiting the same 16 sites 60 days later. Here we dug up the undies and assessed them for level of breakdown. We also did fine incremental soil sampling to a depth of 30 centimetres, and these samples were sent to a lab in WA for a range of chemical measures. We also described and classified the soil at each of the sites. Here's a list of the chemical and biological properties measured at each of our sites. And all these properties, along with their methods of measurement and the labs they'll measured at, as also the field chemical, biological and physical methods that we used can all be found in our final report. The project found certain physical, chemical and biological properties were at desirable levels for a healthy soil and other properties at levels of an unhealthy soil. Organism diversity, ground cover, root depth, organic carbon and aggregate stability were all at good levels. Salinity and acidicity were found to be at good levels at the 16 sites. However, these are known to occur in the region. And in fact, acidicity was measured in the subsoil at one site. Soil pH and exchangeable aluminium, microbial activity, subclover nodulation and earthworm count were all at poor levels, and these are explained in more detail further. Total fungi to total bacteria ratios were lower than desired across all sites. Total bacteria was at desired levels at 2 sites, and potential microbial activity was only good at 4 sites. These included improved pasture paddocks with various fertiliser histories. 13 of the 16 paddocks had subclover and were assessed for nodulation. Scores ranged between 2.3 and 4, and an average score for all 13 sites was 3.2, which is below adequate. For the soil Urundi's test, 15 of the 16 undies were found, 1 pair couldn't be located, and here's some photos of some of the undies that were dug up after being in the ground for 2 months. We found minimal decomposition over the 2 months for all sites. Some undies you could wash and wear, some had blue and orange stains indicative of bacteria and or fungi, and the most breakdown we saw was in 2 pairs that had 1 to 2 spots about the size of a fingernail where the cotton was eaten away and just the elastane mesh left. So why did we not get decomposition like this? And this photo is taken from a site up in Northern Australia. Is this amount of microbial activity normal for our part of the world? Was it because of the cooler than normal spring last year and cooler soil temperatures slowing microbial activity? Or are there other factors at play such as unfavourable chemical and physical conditions for soil microbes? Remembering that soil health is not just about soil biology, but also the soil chemical and physical properties. We know there was enough soil moisture, as we experienced here travelling to one of the sites. So is soil pH and aluminium toxicity to blame? 25% of sites were severely acidic, with pH and calcium chloride of less than 4.5 in the subsurface layers. 56% of sites were moderately acidic, and 19% were slightly acidic. Soil microbes require specific pH ranges in order to survive and function. A pH below 5.5 can reduce the activity of nitrogen-fixing rhizobia, and most strains of the rhizobia stop functioning at a pH of 4.5. As pH drops below 5.2, aluminium becomes available in the soil solution and increases to toxic levels at a pH of 4.8. This affects plant root growth, reducing access to nutrients and water. A comparison between each soil property was made using a linear regression plot in Excel. Only moderate to strong relationships are presented below. Positive relationships were found between total organic carbon and total nitrogen, total organic carbon and labile carbon, total nitrogen and labile carbon, and these three properties and the microbial activity indicators of soil basal respiration, soil microbial biomass carbon, potentially mineralisable nitrogen, and potential releasable phosphorus. This indicates that total organic carbon, labile carbon, and total nitrogen levels increase with each other, and that an increase in these properties generally leads to an increase in microbial activity. Other positive relationships were found between organism diversity count and nodulation score, organism diversity count and fungi-bacteria ratio, rainfall zone and total nitrogen, rainfall zone and labile carbon, and rainfall zone and fungi to bacteria ratio. There were no relationships of moderate or strong significance found between farming systems and any of the measured soil properties within the small sample size of this project. So in summary, organism diversity, ground cover, root depth, organic carbon, and aggregate stability were at healthy soil levels. Soil pH, microbial activity, subclover nodulation, and earthworm numbers were at unhealthy soil levels. An increase in total organic carbon, labile carbon, and total nitrogen levels strongly related to an increase in microbial activity. Labile carbon and total nitrogen generally increase with rainfall due to higher organic matter accumulation. Soil organic carbon, labile carbon, and total nitrogen are found in organic matter, so building soil organic matter in pasture systems is the key to increasing microbial activity. To achieve this in pasture systems, you need to address soil constraints, such as soil acidity, to maximise plant biomass production, and also apply good grazing management, such as maintaining ground cover and biomass year-round. For more information, go to the Holbrook Landcare website. On that page, you'll find a link to the final report, which has more project details. You'll also find a fact sheet which provides some practical ways to measure soil health on your farm, and links to a 4-part soil health video series. Thanks for watching.